Hello class, let's start lecture 37. We will talk about probabilities again. So this lecture we talk about updating probability. I'm your instructor, Miss Laura Low. That will be the last lecture in module 13. And also module 13 also is our last lecture module. In module 14, we will have 2 case study. And module 15, we don't have more lecture. You will just focus on work on your last project. Then module 16 will be week 16, the final exam week. So let's talk about our last lecture. We talk about probability again. Today we will focus on the conditional probability. And we will introduce one very famous rule, Bayes' rule. We use that a lot in statistics and data science. We say that's updating probabilities. We just introduce you more example. In this example, the probability is not just one step. We will have the situation. They have different stage. So different stage, the condition changed. So your probability also changed. So that's why we need to update the probabilities. So in this picture, actually, we show you it's been so many years from COVID. But if you guys remember, I think in the past couple years, any one of us have some COVID test. But those COVID tests, how accurate it is. So we will use the probability to show you to analyze some not only the COVID test for all different kind of medical tests, since they still have their accuracy. So then we will see in what kind of situation we will trust our testing result more. So here is the question actually we want to answer from this lecture. So this one is an interpretation by physician of some lab results in 1978. So in this result, actually, they ask different people. They have 20 health officers. They have 24 years medical students and 20 physicians. They selected 67 consecutive hallway encounters at the Harvard Medical School. So here is the question. So you can try to answer as well. Okay, but at the end, we will show you what is the answer for that. So if we say a test to detect a disease, so we have the chance for this disease is 1 out of 1,000, but we have a false positive rate about 5%. So what is the chance if a person find to have a positive result, but actually they do have the disease, assuming you know nothing about the person's symptom or sign? So what does that mean for this question? This question we just told you. We have a disease. So the chance people get that is 1 out of 10,000. So we do some tests on the to detect the disease. However, this disease, the test, they have 5% false positive rate. So the first thing let's see, what is the false positive rate? So this false positive rate for 5%, that's mean if a person doesn't have the disease, but they test positive. So that's what we call the false positive rate. They don't have the disease, but the test results show positive. So that's the mean false positive. Okay, but our question is not this one. Okay, so at the end, the question we want to ask you is, we just have the random test. So everyone, so here be careful. This question is the person actually don't have any symptoms or sign. So that's why we cannot really see from the person they have this disease or not. Okay, so then we just ask you, according to the test, they have a false positive rate for 5%. So what is the chance the person test is positive and this person does have that disease? Okay, very complicated question, right? So don't worry about that. We will get you the answer at the end. But the interesting thing here is you can see the X 60 people here. So among these 60 participants, 11 of these 60 participants always say that's or equivalent to 18%. They got that answer right. Okay, so we told you the 60 participants, they have 20 is 4-year medical, 4 years medical student, the 20 resident, okay, and also 20% physician. Okay, so not most people got it right, so only 18%, right? But the most common answer given by this 60 people, we have 27 out of 60 people, they told you the chance that the person found to have a positive result actually has a disease is 95%. So is that your answer? So maybe because earlier we say the test false positive rate is 5%. So then we think about the positive rate is 95%. Yeah, but unfortunately, even as the majority answer, that answer is wrong. Okay, but how to find the answer? Okay, so before we find the answer, we need to introduce you more about the probability. So the most important part we want to talk about is the conditional probability. So conditional probability is like earlier we talked about why we need to update our probabilities. Because from the beginning, we have one probability for one situation. Then the condition changed. So that will affect our result, our possibility for each situation changed. So that's what we call the conditional probability. Okay, so that's why earlier that medical question is a little complicated because they have multiple stages. So what is the conditional probability? That's have some example. The first scenario we just want to show you is if we say we have a class, okay, we have 60% the students is the second years. Then we have 40% is they're in their third year. Okay, so in those students, and also we know 50% of the second year students have declared their major. Then 80% of the third year students declare their major. Okay, so that's what we call the conditional probability. The first beginning, we only told you, right, in this whole class, we have 60% and 40% for the second year and the third year. But for the second year and the third year, because third year, you know you're more clear about your major. So we have more students, they declare their major. Okay, so then that's actually. So now we pick out one student at random. Okay, so can you tell me which is more likely? The student I pick is second year or third year? Yeah, this question, if you want to answer, we just need to see the first bullet, right? Because we only select by random. Okay, so then we ask you, is be second year student or third year student has more likely? Yeah, because second year is 60%. So of course we say the second year because if they have more, they are the majority of this class. We have 60%. Okay, so this question is fine. So this question actually is the probability we used before. We just see here, we told you, second year student will have 60%, then third year will have 40%. That's our answer. Okay, then continue with this question. We slightly change our question. We still have these 3 bullet correct. We have second year and third year students 60 to 40. We have 50% the second year student declare their major. We have 80% third year student declare their major. Again, the same thing. I pick a student at random. But I'm not only ask you they are second year or third year. I just ask you. I pick one student at random and these students declare the major. So can you tell me these students more likely to be second year or the third year? Okay, so which one? Okay, so hold your answer. Now we will talk about more, but actually here, write down your answer first. Then we see our demo. Then you see your answer is correct or wrong, okay? Okay, so now go to our demo. In our demo file, of course, we have some library we want you to make sure you will include. So please make sure you run through that. And also we do have one function we will use later. That's what we call create the population. So that's using for our medical test example. But the first one, let's talk about that student question, okay? So here we told you we have the student, right? Okay, so we just show you the student look like this. We have 100 students. Okay, of course here we only show you the first three. Okay, so of course we have 60%, we have 60 second year students, we have 40% third year students. And among that second year student, 60 second year student, they have declared their major, have not declared. Okay, so then the same thing, your third year, we have that too, but we have 80% they declare. So then in order to find, then we told you we select student by random, okay, and we know these students declare their major. So we want you to ask you, these students will be second year or third year, more possible to be second year or third year. So in order to get that, since we have our major and year, right? So let's do the pivot. Okay, so that's why we can group them. We group according to the major and the year. So you see here we have students with second year and third year. Then we have 50%, you see, because we have 60 second year students. So we have 30 declare, 30 not. Then we have third year students, total 40. So they're 80%, that's 32 they declare. Okay, so from here, that's easier to see, right? Since we told you the student we pick by random declare their major, so that we know they are only in the second column. Okay, so if they are in the second column, total we have 62 students, but third year student have 32. Okay, so that's why we know there's more chance is the 32. The third year student, that's the student pick, they have to declare their major. Okay, but then we can do one by one, of course, here. On this one, actually, we just verify each one. We just want you to show you the data is correct. For example, we have 60 second year students. Then 50% they are declared their major. Then 80% for the third year student, they declare their major. But earlier you can see the data, we see that. So that's why back to our question here in the scenario 2. Okay, so since we told you the students declare the major, so the student declared their major. So that's why when we check, we only check the second column. So that's why if this student is second year, we only have 30 out of 60, 62. If the student is third year, we have 32 out of 62. So then we can see, right, not only third year student is more likely, and also we know the percentage. Yeah, so that's our example about the conditional probability. So did you get that right? Yeah, so earlier, yeah, we know third year is more possible. But also one thing is, if we want you to know actually what is the chance for each one, so then you need to know how to calculate that. So this one we call the conditional probability. So conditional probability, we can, like here, we can just make the table to list all the person, their declare, and the year here. But we also have the other way to do that. So we will talk about the base rule in the next video because we only have 1 minute left. Okay, so that's our conditional probability in the first lecture video.